Hello and welcome to the show. My name's Relevant. This is Do All the Things. Little slip of the tongue there. On today's episode, I am building an Op-Amp Big Muff Pi, or an Op-Muff Pi, or a Big Op-Amp Muff. It's orange. So I'm on a little bit of a pedal building kick here because, well, it's a lot of fun. And I've always been curious about the Big Muff Pi. I've always wanted to try one of those out. So I decided, hey, let's try that one next. Except I discovered they have an op-amp version of it. I'm like, you know what? I'm gonna go for that one because I'm also on an op-amp kick. It means I'm gonna be able to try some of my various different flavors in there and see what kind of results we can get. Now I'm going off of this schematic here that I found online. Not sure how well it's translating. It looks kind of, choppy here, but it seems to be mostly truly representative of the Big Muff or the Op Muff. I'm gonna refer to it as a Big Muff, just bear with me. It also features certain modern updates that I'm not sure what version of the pedal had this. There are so many different versions of the Big Muff. Not sure how many different versions of the Op Muff there are. Like, for instance, add another 10U here, bud, and maybe disconnect that and bring it straight to ground, bud. Oh, sure. Now, there's another schematic that I found, and it says explicitly on the schematic not to be posted anywhere else, so I'm not going to show it, but if you search for the schematics for this pedal, chances are it's going to come up one of the first few results, and it recommends some component changes like a 180 here instead of a 150, and over here on the tone circuit, a 150 instead of a 120. So I've implemented those in my design. And what's my design? Here it is. Oh boy, and it's a doozy. In fact, I even just made some last minute changes to it that should work just fine, but maybe optimize the layout a little bit different. Now, I cheated when I put this layout together because I kind of went off of this image that I found of one of the retro versions of the Muff, one of the original versions of the Op Muff. And so I kind of used this as a jumping point, you know, a launch pad in which to start designing this circuit because, well, there's a lot going on and I was scratching my head at first. Well, let's look at some other, screw it. I'm just going to kind of go off this one. Now, obviously I've made several changes to it and ended up coming up with this. Now, what's significant about this is I've formatted it to fit a typical 5x7 perf board because that's what I'm going to be working with. And then this is a Hammond 1590 is what they're calling them? Yeah, 1590B3OR. It's the 3. It's the 1593, which is a slightly larger version, which should perfectly fit this size perf board. And of course, we have 3 knobs. Again, I'm using my TT Electronics POX9 type pots, the X being the number of gangs. Depending on what values you want, some in stock might have 2 gangs or 1 gang. We only need 1 gang. And so this, as a perfect example, was a 2 gang version, which I am just going to convert to a 1 gang right now. Oh, such a waste, but yeah, that should be good just like that. This is the A100K. And then the tricky part is figuring out where to put these pots because you have 3 knobs. And I'm going with a kind of offset here. I tried to centralize them, but unfortunately these pots have an odd number layout, an odd number footprint, and the perf board has an even number of pads. So I was never going to be able to get that perfectly center. So I said, screw it. In this version that's not in this layout that I found, it's got the tone bypass. And I got this tiny little switch, E-switch part number, I don't know, I'll look it up, ask if you really care. It's gonna fit right in there, and we're gonna have kind of like a little tone cluster in the middle. So that's gonna be our volume, that's gonna be our sustain, that's going to be our tone, and then boom, tone bypass. Tone on, tone off. Spacing it that way, I don't know, has enough symmetry for my purposes. So that should work. Mounting that switch is going to be tricky. I'm going to have to like solder it into place absolutely first to get underneath to get it onto the pads because this isn't a double-sided board. And for the most part, all the connections going to that switch are going to connect directly to the terminals on the back. And of course, part of the challenge here is reversing the potentiometers. In the circuit layout that I saw, the potentiometers are on the same side as the components. But because of the way I design things, my potentiometers are on the solder side of the board. So the layout layout, we're looking at it from this direction. It's caused me to make mistakes in the past building these pedals, because you gotta like think upside down and backwards while you're doing it, but I like the way it works out, because our pots will suspend this board. Oh, the other mod we're doing is this 820 is being replaced with a 1 meg, so it can accommodate a wider variety of op amps. I'm pretty sure the 1 meg/1 meg voltage divider here is going to accommodate the 741 that this calls for, but there's a very good chance I'm not going to use a 741. There's so many better op amps out there, ones that I'm sure are going to sound better in this pedal. Just looking at the way it works, I think at the last minute I'm actually gonna, yeah, the circuit looks good. Oh, it's gonna be intense because some of these guys get so close together. And you're gonna notice I got a couple red lines here. That red line is going to be some sort of jumper on the component side of the board because stuff's gonna get awfully congested. We have circumstances like right here where we got 4 pads. Each one of these dots that you can barely see is a pad. But when you start dealing in quad pads, you have a problem that you have to come across, because if you get a wire going diagonally, it's very difficult to solder a wire diagonally without it accidentally contacting the 2 pads it's going in between. So basically every 4 quad pads, you have to expect them to connect together. So if you have situations where they're gonna come really tight passing through each other, it's best to go overland. And indeed, there's a few red traces all over. But all in all, I believe this layout's solid. So let's give it a try. Now, in this case, it's do or do not. There is no try. One of the first things I need to do is get this switch mounted. Yes, it goes there. Because like I gotta get at the pads all the way in underneath there. Oh, thanks, Obama. Oh, I was just making a wicked mess. I'm not sure that I'm actually reaching those pads. You probably can't see what's going on here, can you? Oh my god, this is just making a mess. My first challenge, mounting this switch. Oh. And instead of mounting the switch, I'm f***ing up the board. These pads are like glued on here. Wow, that started off devastating. I might as well scrap this board and get a fresh one. I can cut that in half, use it for a different project. Okay, well, we're going to pre-tin the contacts on the switch. I'm gonna flux this so that it doesn't make so super a mess of everything. Now, let's see if I can't, oh, okay, we'll just bridge the contacts. Okay. I got it in there just to have it rip the pads off. These are the shit perf boards. All right, so this isn't starting off very well. Like that switch is not gonna have a very solid mount. So I'm not sure if you could tell, I'm waiting for glue to dry. I've just straight up gone and hot snot glued that switch to the board, and hopefully that's going to be good enough. Fortunately, according to the layout, on the solder side of the board, there's not that much going on around, so I got room to do that. Almost blocked an important hole down here, but I'll be able to clear that glue away. But hopefully once that gets solid, that'll hold the switch well enough that we can work on it, because all the solder connections to the switch, oh geez, I've glued it to the vise. This is certainly turning out to be a more interesting build. I'm gonna be connecting the contacts to this side, so not the solder side. Sucks, I've ordered another 8 of these perf boards for upcoming projects. Oh, that's not good. I need a resistor to come through there. Oh, this is going great. Okay, I guess I'm not gonna be able to make a resistor go through there. You know what, I'm already thinking this is gonna be fun with how close some of these things are coming together. All right, pray for me, Argentina. Okay, so that took 3.5 hours. And I'm not exactly sure how I'm gonna edit this. If I'm gonna do a time lapse or if it's just like, hey, look, it's done now. Ah, look at that. Would you look at that? Now tell me, does this look like that? Well, you know, you're not gonna see much of it. Half of it is on this side. Lots of delicate surgical work there. But hey, it all worked out quite perfectly. Now, I made some adjustments to the layout as I went along, you know, shuffled some components around a little bit because how they fit on design and how they fit in real life is a bit different. And actually, I found that some stuff fitted better. Or the tricky parts is these capacitors, they're a bit fatter than represented here. So some of those got moved around. But hey, for the most part, the only wild card was this switch, but I think it's gonna be fine. It's glued on there. I think it's gonna stay put. Then, you know, easy peasy. Attach the wires. White is in, blue is out. And then red and black is pretty obvious, isn't it? I also, you know, there were some changes to the overland runs, the jumpered runs. Some were added, some were moved. You know, again, figuring out what works while you're actually doing it. But yeah, now we start assembly. As you can see, I already coated the box in the painter's tape. Well, not quite coated. That's gonna stop it from getting scratched right up as I start putting it together. I guess I'm gonna use one of these black jacks. They're gonna look nice in the back of this guy. Now we start the process of measurement. Roughly 75, right about there. Center enough, maybe 34, 17. All right, gonna start off by calling in the consultant. And we get messy. Goes faster if you have two drills. One to pilot and one to actually make the hole big. You do not need that much power for the pilot. In fact, you kind of want to go slow. You'll get a cleaner cut. That power jack uses a 1/2 inch hole, I think. Let's double check. Yep, one more. Let's pop this in for reference and see how much room we have to seat the PCB. Fortunately, this particular enclosure is gaping, so we're not gonna have any problems making room for anything in here. Well, I figured how much room we want to clear that and mark where that pothole's gonna go. And use my square to copy it around front. Now, to figure out where these actual holes is gonna go is tricky. So it mounts in this general orientation, therefore, you have to kind of go like this, and I have to position it so that I can see well, so here's secondary. Because it goes like that, I'm gonna tilt this down. I'm gonna mark where the center of all these things is. So we got a pot center here, pot center here, pot center here, and a switch center here. Now, that switch is sitting down more. It literally looks like top of the switch lines up with the center of these pots. So this is the top of the switch. So the actual hole needs to be lower. Now I'm gonna be grommeting it, so I need to make a bigger hole than the actual size of the switch, but still, 4.7 millimeters. So we're gonna lock the caliper, 4.7 millimeters. If we put it on the inside, there's our hole there. So we gotta get center of this. We're gonna say roughly here. Hopefully that's gonna give us a good enough margin that switch is gonna fall into place. Hopefully. Oh well, here we go with the consultant. Switch goes here, pot goes here, pot goes here, and a pot goes here. Yeah, pretty much. I can already tell you that freaking walked horribly. Oh, you bastard. Why did you walk? You've got a nice sharp center, bud. Oh, this is gonna be a problem. The problem is fitting that switch, right? So what is this, our new center now? Yeah. This is gonna be fun. Okay, that looks like it stayed. Establishing new centers. Now that switch is going to be a problem. 4.7 mil from the new center. Just like the last guy. Down just a scotch. Well, hopefully that grommet's going to give us some margin of movement, right? If our hole's a little bit off, it will cover up the imperfections. How big is this grommet? 7.29 millimeters. It's got to be a 5/16 hole. Yeah, okay. Means it's probably going to be bigger than the actual potholes, which are 6, 8, 9. Actually, they're all going to be 5/16 holes. Okay. All right, let's see how well we did. Oh yeah, that switch hole is like off in the sticks. Oh, that switch hole is freaking awful. Oh. Okay, well, that's amazing. Let's pop a grommet in there, see how much we can cover it up. There are certain aspects of fabrication that I'm still trying to master here. I was going to put a chassis mount switch like over here, but I ordered the wrong part. This isn't the part I ordered that I'm using. This was another part because I was going to try doing this way. I ordered the correct switches, but I was one part number off, so I got the versions without hardware. So no way to mount them. Come on, buddy. Get through your hole. Go through the hole. Actually, you know what? That's gonna be not too bad. That's gonna be right where I need it to be. And then is it gonna clear the knob next to it? Close, but yes. We're gonna be good. It's one reason why I went with the grommet, because I knew making a perfect size hole for just the little switch was gonna be way too tight of tolerances for me to be able to nail with my tooling. Or, you know, maybe if I took the time to set up the drill press. Now we have that piloted through here. Like everything else is just gonna chuck in there. Get this guy here, roughly here. go up just a little bit right here. Got a standard jack on this side. Tool will just put roughly central. I'm gonna drill those in next and then fit where I'm gonna put the push button switch. Now this guy is a little bit bigger than your standard. 10.8 millimeters, 7/16. And then before 7/16, 3/8 is what the standard jack will do on this side. So lock that up. Now, battery is gonna flop right in here like this somewhere. And then the switch is gonna sit right above the battery there. So, I'm gonna remove one of these now. Bring the battery right up to here and the switch right up to here. Give the switch just a little bit of relief. My head keeps getting in the way, doesn't it? Mark the switch position, copy it through. Aha, that's where the switch is going. Just wanna find center. Oh, it's exactly 3 inches actually. So right at 1.5 should be good. And because our hole saw is going to go deep, we need some space. Because that switch is also, I believe, a 1/2 inch hole. Right, 1/2 inch hole? Yes. Take the edges off here. I gotta clean retool this bench for assembly. Final assembly. Get all the crap off of it. I'll actually spray down the bench to make sure there's no sharp debris still there. Oh, y'all ready for a satisfying peel? Oh, fresh and cute. Put down something soft. All right, so start with the power jack. 14 mil wrench. Get this guy ready, because positive's just gonna tie together. And my power supply that I like to use is actually center positive, so I'm gonna be wiring it that way, but that's okay. You could just do that as it suits you. Yeah, the red wire on the PCB. I know it's not a P. It's going right to the battery jack. I'm gonna orient the wires so that they face downwards, because that's the direction the wires are gonna be running. Battery negative goes to the switched terminal on this guy. Switch terminal is the inside looking one. But you know, we should probably get the other negative into place because it's gonna be harder to access. So this guy is coming from the jack, roughly right about there. It's gonna come from the sleeve of the jack, so we'll cut that to length. This should be about right. You'll notice I keep the wires I attach stuck to the spools, so I cut them to length. Less waste wire that way. Okay, you stay in that position there, and let's just get the battery hooked up. Why are you being weird? All right, now that those are in place, we can pretty much put our circuit down. I'm gonna arrange these wires that way, this wire to come out that side. Gotta get our grommet in our place, our special little grommet. This grommet looks old already. Oh, come on, buddy. Why aren't you going in the hole? There you go. Wires out from underneath the pots, just like that. And that should be sitting well. Let's get the hardware on these pots. And these guys use a 10 mil wrench. That's nice. Oh, you I heard you fucking snap off the board. I better inspect it. Just tweaked it a bit. It seems okay. It's still in place. Probably gonna reinforce these with some glue. Give it a minute to cool. I need star washers for these things. Can't find ones the right size. Not too tight because it can straight up break the pot off the board, unfortunately. Ha! This is coming together. Yes. Gonna get the input jack in place. I like to use isolated input jacks so I can control my ground. So this is the power line. It's going to connect to center pin there. Twist, a little tin on the end there. Then this line, negative off the board, is going to go to the ring terminal. Except it's not alone, so let's get another wire ready. And this one, I want it to be underneath the jack and come up and around. Like that. So we're gonna tuck it and then attach it. Now if you're shopping on Mauser and you search Star Washer, you're gonna get this guy. I think it's a Switchcraft part. That's important because we want to bite into the metal of the enclosure when we fasten this jack down. That way we know we're gonna have a good ground connection. Figure out how long we want this wire to be and snip. Now we have a proper ground bus. You gotta watch out that that doesn't touch. Now we just have to settle on our I/O, which is going to involve installing the stomp jack. So for this particular guy, it's very straightforward. We just have a simple case of the input is tapped and then passed through to the switch, and the actual output is switched. So that makes our job rather easy. Entails taking the input line, bringing it over to the jack. We'll get our switch line in there. We'll get our board line in there. solder it up. And our output line, which I would have liked to have run before, we'll do it roughly there. Just pick a side, bud, pick a side. Unfortunately, it's hard to pre-tin these wires because they will be difficult to get through that hole if you do. Just use a little snippet of whatever wire here. The center. I'm gonna solder up that center terminal while we can get at it easy. And this white wire, we're wrapping it around all cute. And finally, this green wire we stripped out. Well, that is our main output. Oh boy, I think we're done. Assembly takes an hour. Assembly doesn't really change with different pedals, I find. It's bad luck to put the knobs on. Well, I want to see it with the knobs on, but I don't know about you. I got these nice little dillies. I'm gonna start with this one because this one, the part that I got, it doesn't point in the right direction, so it's technically upside down. So I kind of want to make sure that we can get this to, yeah, pretty much. Ah! Oh, I think it's done. Volume, tone, sustain, tone, tone bypass. Hopefully. Hopefully this switch didn't get damaged in the fiasco earlier. Gotta make sure this guy doesn't touch anyone. Stuff a bit of foam to keep it into place. Well, we gotta put in the crystals. Pretty much what the schematic says. Our basic, thanks Obama, our basic op amps. Which one goes on which side? I just realized I put this socket in backwards. The little pip's supposed to be facing that way, bud. Oh, well, that's a miracle. As long as I know that the pip is actually on this side, it will be okay. Because there's no actual orientation for these sockets, so you can pretty much put them whichever way you want. But if I recall, the 741 is going to go on this side, and the 4558 goes on this side. Oh, she should be ready to fire up now. She should be ready to figure out what mistakes that I made. Huh. Last pedal, I got some wires crossed. How much juice is in this battery? Let's try it. I grabbed whatever amp from the other side. It's not mic'd up or anything. It's late. I'm gonna test that this thing works. And then we're done. Where's all our patch cords, bud? I just had them. Our amp's too far. I did not anticipate this project taking as long as it did. Well, no, I kinda knew. I just dove in, right? There's no tubes in this amp, isn't there? Oh, I'm missing multiple tubes. So the crate I got set up here's got a pretty good clean channel. If only the volume wasn't touchy. Okay, the amp works. Tone works. Volume works. It's gonna take some getting used to figure out how to dial this pedal in. So needless to say, that's not happening in this video. I'm gonna have to play around. I'm gonna have to set up an amp. I'm gonna have to mic that amp. Apparently this will sound good with the JCM 800. Apparently Smashing Pumpkins used this pedal with the JCM 800. And my JCM 800 takes some of these pedals well, actually. I plugged the fuzz pedal. It's my favorite place to play. It's my favorite amp to play the fuzz pedal onto, so that's something. It seems to work fine. I don't know if this is what it's supposed to sound like, if I made a mistake or something. It sounds fuzzy, but I do believe this was marketed as a fuzz pedal to some. There is one thing I'm gonna do before we leave. See, I have no intention on using the 4558 and the 741 in this. I highly doubt, out of all the op-amp combinations I could possibly come up with, that's gonna sound the best. Highly doubt it. So, our 741, and which would be nice if I remembered the extraction tool, is getting replaced with an RCA 3140E because it has a good mid-grind to it, like the most mid-grind out of all my op-amps. So that is what's going to generate our distortion. Whoa, some flex on that board. And the 4558, look at this pupper right here. That is a Burr Brown 2277. Fresh, going in there to give this some drive. So let's see how that's gonna sound. Gonna have to turn the drive down just in case. It immediately sounds better to me. that's been an adventure. I swear I've been at this pupper all day. At least it feels like it. And I don't know about this sound. Yeah, I guess it's a fuzz pedal. I guess it's gotta give me a fuzzy tone, isn't it? Oh boy. It's just a case of swapping through on the op amps in this thing, seeing what I prefer. So, for a better taste of what this sounds like, once I figure out how to make it sound, stay tuned. Stay tuned. Did I mention stay tuned? Ugh.